In this video, we will answer the question, how can the area under a curve be found by anti-differentiation or integration? So first, I would like to discuss to you integration, the integration process. Integration process is the reverse process of differentiation. So let us first review differentiation, or a review of the power rule. So to review the power rule, if you have a f of x, x to the power of n, so to differentiate or find the x prime of x, or the dy over dx, or the slope of the curve, so you just need to bring down the exponent in front of the x and then n minus 1. So that's basically the power rule. So for example, we have f of x is x cubed, then f prime of x, or the derivative of x cubed, will become 3x squared. Another example, so if your f of x is equal to 5 over 4 plus 6x squared plus 3x plus 2, so 4 goes in front of the 5, it becomes 20, then it will only be x cubed, and then 2 times 6 is 12, it will only be x, so 3 to the 1, 1 times 3 is 3, and then x to the 1 minus 1 is x to the 0, which is 1, and 2 disappears, so this is your prime of x, f of x, f prime of x. So since the integral calculus is reverse of the differential, we will try to reverse the process. So let's compare. So this is when you took the differential of x cubed, it becomes 3x squared. So we'll try to reverse the process. So basically, let's compare. So f prime of x, or let's say f of x, is equal to 3x squared. So let's get the integral. Let's get the integral of f of x. Integral of 3x squared. So how it can become x cubed? So what happens is, you add 1 to the exponent, and the new exponent goes underneath the, it becomes a denominator, so 3. So 2 plus 1, so this becomes 3 raised to the 2 plus 1 over 2 plus 1. So this becomes x cubed, 2 plus 1. So the 3, the denominator is cancelled out with 3. So that's the reverse. So this is basically the formula. X, if you have x, the integral of x to the n will be equal to x to the n plus 1 over n plus 1. So let's I'll try to make it as simple as possible. There are some other things I have not included. So for example, we have the f of x. So these are more examples, more complicated. The f of x. I'll be using this one. So for example, your f of x is 20x cubed plus 12x plus 3. So applying this equation, so this becomes 20 x to the 3 plus 1 over 3 plus 1 plus 12 raised to the x1 plus 1 over 1 plus 1, and this is 3. This one is actually x to the 0. That's x to the 0 is 1, so x to the 0 plus 1 over 0 plus 1. So what we have is 20 x to the 4th over 4 plus 20 x squared over 2. This is plus, sorry. Plus 3x. Yeah, so this was 3. Now if you compare this one to the original one, let's finalize this one. 20 divided by 4 is 5, x to the 4th plus 6x squared plus 3x. When we compare this one to this one, notice there's a 2 in the original equation, so let's just put plus c, which, because if we don't know the original, because it's just a constant, but we will talk about this later because this will be cancelled out anyway. So this is the basic rule, and I will explain later why this is not critical to know for the purpose of finding the area. To explain integral calculus, I have prepared a simple example so that there will be less confusion and make it more easy to explain. So the example, a man is walking at a constant speed, and after walking for 4 hours, he traveled a distance of 8 kilometers. What is his speed? So the time, the distance, the time that he did was 4 hours, and then the distance is 8 kilometers. So he started walking at constant speed. So this is the speed, and we can compute the speed by using the distance and the time. So the distance is, the speed is, so the speed is also the slope. So the slope is the rise over the run. So for this case, the rise will be from here to here, that's 8 kilometers. And then the run is 4 hours. So the speed or the slope is equal to 2 kilometers per hour. Now we can make the equation. We have the y-intercept at 0 and we have the slope 2. So using the slope-intercept form, you have y is equal to mx plus b. So our case is 2x. So this y-intercept is 0, so we can leave it as y is equal to 2x. Now we can also graph this in terms of the speed and time. So let's say this is the speed in kilometers per hour. So let's say 1, 2. So the speed is constant at 2 kilometers per hour. So it's not the slope is not changing, it's not curving. So it's constantly at 2 kilometers per hour. So this is the speed. So kilometers per hour. So if we graph it with the speed against time, it will have a constant line of 2. So if he continues walking, then it's always 2. And if he continues walking without changing the speed, the line would always be straight at 2 kilometers per hour. He's walking at constant speed. Now, if we want to, for example, he has been walking constantly for 2 kilometers per hour. If, for example, we want to know how far has he traveled after 3 hours. So let's just 1, 2, 3. After 3 hours, this is be, so we multiply, so distance, so speed is equal to distance over time. Okay? So if we want to compute the distance, we multiply time on both sides. So I'll just do the initial. So time times the speed is equal to the distance. So if we have time at 3 hours, and the speed is 2 kilometers per hour, then the distance would be, so this r's and r's cancel, 3 times 2 is 6, which is basically this area. So 2 kilometers per hour constantly after 3 hours. So 2 times 3 is 6 kilometers. Now we can also use this one. We can also use this one to compute, because we have the speed, we have the slope. So this is 4 hours. If we use this 3 hours, so this is 3 hours, we can put it up and then go to this one. We have 6 kilometers. So we can also use this graph to compute for the speed using the graph. Now, so if we have this graph, and we want to go to this graph, we can use integration to get this one, and then we can find this area. This area is equal to the height of this graph. So let us use, so we still have the same, so the slope in here, so the slope is the dy dx, dy over dx is equal to 2. So this is the, this is your slope, this is your equation, dy dx over is equal to 2. So we have dy over dx as our slope. Now, if we want to go back to the original equation, we have to integrate this value. So to integrate value, to integrate 2, remember 2 is has x to the 0. X to the 0. So the formula is 2x. So that's you add 1, so 0 plus 1 over 0 plus 1. So this becomes 2x. This is now your equation, your original equation, 2x plus c. So you go back to the original equation. This is your y, 2x plus c. So the c in this case we had c at equal to 0. So this is 0. I will explain later that one. This one, I will explain that c later. Now that we have your original equation, you can use this equation to solve for this area. If you want the area at 3 hours, you can substitute here 3. So this is 0. You substitute 3 to x, so 2 times 3. Your y is equal to 6. So this shows that the area of the of this, like this is not a curve, but it's a simple equation. The area of this one is equal to the height of the origin of the integral. This is the integral. The area of this one is equal to the height of that one. Now the C, if you have an equation like this, so it would still be the from here to whatever you prefer the value is, and then so this will be the height. This is the C. This is the C part. So the C, it won't matter because this C will not be considered. Anyway, this shows that the area can be found by taking the integral and getting the height. Here is another example. We have a line passing through points 0, 3 and 4, 4. We can get the equation of the line by solving first for the slope, and we know the y-intercept is at 3. So for the slope, we have the rise over the run. So using these points, so 4 minus 3 is, let's say, rise over the run. So 4 minus 3 over 4 minus 0. So we have 1/4. So that is our slope. And then the y-intercept is 3. So our equation is y is equal to 1/4 x plus 3. So if we are, for example, we are interested in finding this area, let's try first finding the area using the shapes. So there are simple shapes. So this is a triangle. So the first area would be, so it has a length of 4, it has a height of 1, so 1/2 of 1 times 4, so that would be 2. So the area of this triangle is 2. Now the area of this rectangle is, this is 4, this is 3, so 4 times 3 is 12. So the total area is 14. Now we can also use integration to get the area. So let's integrate this one. So integral of x, let's say x over 4 plus 3. Now I just like to add, this is from, so the area that we want is from 0 to 4. So we put the number here from 0 to 4. So the span is from 0 to 4. So to integrate, we have, I'll go straight to the solution. So x becomes x squared over 4 times 2 plus 3x. So this is x squared over 8. Sorry, this is no longer integral. It's already the answer. So plus 3x. Now we have to plus c. Anyway, plus c. So we have to assess this one from 0 to 4. So this is how we answer it. We will place 4 in here and then 0 in here to evaluate. So this will become this becomes 4 squared over 8 plus 3 times 4 plus c minus, so this is for the number 4, for 0 squared over 8 plus 3 times 0 plus c. So 4 squared is 16 over 8 is 2 plus 12 plus c minus, so 0 minus 0 minus c. So this is 14, which is the same area as what we have in here. So we can also use the integration. Here's another equation, example. So our equation is y is equal to x over 3 plus 1. Now, for example, we are interested, this is the line of this equation. So for example, we are interested in getting this area. So this one is not included, only from here to here. So this is 3, this is 12. So we are only interested in getting this area. So we can compute first the area manually because it's just a triangle and a rectangle. So the distance from here to here is 9. This is 2. From here to here is 2, and then from here to here is 3. Let's put a point, make it easier. 12 and 5, and this point is 3, 2. So we have, so the area of the triangle will be 3 times 9. So the area first is, area 1 is 3 times 9, since it's a triangle, divided by 2. That is 13.5. Now the area of the rectangle would be 2 times 9. 2 times 9 would be 18. If you add this one and this one, the total is 31.5. Now let's use the integration process to find the area. So we have the equation y is equal to x over 3 plus 1. So let's integrate x over 3 plus 1 from, so we will get the from 3 to 12, from 3 to 12. So getting the integral, we will have x squared over 6 plus x. So we will evaluate this from 3 to 12. So first we use 12 to substitute to x. So that will be 12 squared over 6 plus 12. Minus 3 squared plus 6 plus 3. Actually, there's a c in here, plus c, but it will cancel out anyway. So let us, so 12 squared over 6, so 144 divided by 6 is 24, plus 12 is 36. So this, all of this is 36 plus c minus, so 3 squared is 9 over 6 plus 3 is 4.5 plus c. So 36, so that would be 36 plus c minus 4.5 minus c. So that would be, this will cancel out, plus c minus c, so 36 minus 4.5, this is 31.5, which is the same area as when we computed manually. So I mean, I just want to emphasize, for getting the area, we don't need to add the c. We can go straight without adding the c, the constant, because it will cancel anyway. Our last example is a curve. It's a parabola, and we are interested of finding the area between from 2 to 5. Now, so we're only interested in this area. So from 0 to 2 is not included. So we would like to find the area from 2 to 5. So the equation of this curve is this one: f of x is equal to x squared. Now we can integrate x squared from 2 to 5. So if we integrate x squared, it will become x cubed over 3. So we have to evaluate it from 2 to 5. So first we substitute 5 into x, so this becomes 5 cubed over 3. So that's and then we evaluate it with minus 2, because we don't need this 2. So 2 cubed over 3. So what we get is so 5 cubed is 125 over 3. 2 cubed is 8 over 3. So they have the same denominator. We can subtract directly. This is 117 over 3. So our area will be 39 square units. Now we cannot directly measure the area by normal standards, normal methods. So we can divide it into 3 and try to approximate. Let's try to use the middle point. So it will be this one, middle point, this one, and this one. Hopefully, I mean, we will be measuring this area, but we will be subtracting that part on top. So approximately it will be similar, very close to this area. So first, to get this point, it's between 2 and 3. So this is actually 4. This is 9. It's the average of 4 and 9. So 4 plus 9, 4. So the area of this one, area 1, is 4 plus 9. 4 plus 9 divided by 2 is 6.5. Because the span of this one is just 1 unit. So multiplied by 1 is still 6.5. Now the second area, area 2, so this is in between 9 and 16. This is 16, this is 9, so we get the average. 16 plus 9 over 2, this is 12.5. Now the third area, so it will be 25, this is 25, this is 16, so we get the average. 25 plus 16 divided by 2, that would be 20.5. So if you add 6.5, 12.5, and 20.5, you will have the area of 39.5, which is not far from our original from the area computed by integration. But this would be more accurate than this one. This is just an approximate. So this area 39 is a more accurate measure of the area. So that's it for my integral calculus, and I hope you are able to understand the principle of integral calculus, why we can get the area by using the integral, And yeah, that's it.